So now that we've discussed buffer solutions in pretty good detail, we can do different example problems. In this example problem, we're asked what mass of sodium acetate must be added to 0.030 liters of a 0.25 molar acetic acid solution to produce a solution with a pH of 5.09. And the Ka for acetic acid is given as 1.8 times 10 to the minus 5. So whenever we're calculating problems with buffer solutions involving pH and concentration, we're going to use the Henderson-Hasselbalch equation, which is the pH equals the pKa plus the log of C2H3O2 minus divided by the concentration of HC2H3O2. We're given that the pH is 5.09. Our Ka is 1.8 times 10 to the minus 5. If we take the negative log of that, we get 4.74. That's going to be plus the log of X, which we'll say is the concentration of the acetate ion, divided by the concentration of the acetic acid, which is 0.25 molar. If we rearrange this particular equation, we get 0.35 is going to equal the log of X divided by 0.25. That means that 2.24 is going to equal X divided by 0.25, and X is going to be 0.56 molar, which is going to equal the concentration of C2H3O2 minus, or the concentration of the acetate ion. So if we have 0.56 moles of C2H3O2 minus per liter of solution times 0.30 liters, our liters cancel out and we're left with moles of C2H3O2. For every 1 mole of C2H3O2 minus, there's going to be 1 mole of NaC2H3O2. And if we look at the periodic table, 1 mole of NaC2H3O2 is going to be equal to 82.0 grams. And when we multiply all this out together, we get 13.78 grams, which is going to be equal to, two significant figures, 14 grams of NaC2H3O2. So when we're looking through each of these particular problems here, we need to determine, first of all, what this is kind of asking for and what equation we're going to have to apply. Most of the times when you see buffer type problems, we're going to use the Henderson-Hasselbalch equation, which relates the pH to the pKa plus the log of the concentration of the base divided by the concentration of the acid. Here we're given everything, and we can go through and solve for the concentration of our base, which is going to be our sodium acetate concentration. We go through and do that, and we get 0.56 molar for this particular case. We convert the molarity, or when we multiply the molarity and the volume, we'll get number of moles. We then can convert the number of moles of the acetate ion to number of moles of sodium acetate, then multiply by the molecular weight by using the periodic table, and we end up getting 14 grams of sodium acetate need to be added to 0.30 liters of a 0.25 molar acetic acid solution to give a pH equal to 5.09.